Alright, let's make a start on integration. Before we do that, let's just look at what we've learned with differentiation. We know that if y equals ax to the power n plus c, then the gradient of y, dy of dx, equals, the power comes down, you take 1 away from the power, and any constant just becomes 0. So that's what we know so far. Agreed? Right. What I'd like you to do, let me pose you a question. Say I've got a couple of questions like this. And what these are the differential equations. In other words, this is what you get when you differentiate y. I'll give you 2 minutes. I'd like you to tell me what y could be. Okay, work in pairs, have a little think about it, and then we go for it. Off you go. Okay, so with part 1, you've got dy of dx equals x cubed. So let me write down part 1. What form can y take? Anyone? X to the power 4 plus c. Hands up if you agree.
No.
Go on.
Wouldn't it be 1 over 4 x to the power 4 plus?
So you're saying let's add a quarter in there. Yeah? Hands up if you agree. Okay. And let's just see what happens when you differentiate it. If we want to differentiate this, dy of dx, you bring the power down, take 1 away from the power, and that c just becomes a 0. So these 4's cancel. So you know x cubed. What about, let's just do the second one. What about if you've got dy of dx equals x to the 6? What form is my y going to take? Anyone? Somebody else? Go on.
X over 7 comparison.
Excellent. Is that okay? Should I add anything here?
Plus C.
Plus c. Alright, let's think about this plus c. The plus c is an arbitrary constant. Why do you need a plus c in there? This is why. Here's something I prepared earlier. Okay. Here I've plotted the first function where you've got x to the 4 divided by 4 plus some constant c. And this constant, I can move this around. See, I can move this around. Okay? And when we say it's a plus c, we're saying that c could be anything, it's going to cover all the cases. That arbitrary constant is a general solution. It's not a particular solution, it's a general one. A general means it covers all the possible scenarios that can possibly happen. It works for all of them. So in other words, if we were to take the gradient of fx, we get f prime x. So if I plot the gradient on every single point on fx, I'll get the red line here. Now look what happens when I change plus c. There's a gradient function change. In other words, the gradient function for all of these possibilities, no matter what c is, okay, as long as it's some sort of real number, is always going to be the same. It's going to be x cubed. And so that plus c factors in all of those possible variations that you can have. Does everyone understand that concept? Right? So that's our general solution. Alright, let's go back to our example. And let's now set out the whole platform or the whole sort of scenario for differentiation. What I'm going to do is draw a staircase. A 3-step staircase. On the first step, I'm going to write fx. Let's just make up some function x to the 4. Doesn't really matter. And on the next stair, I'm going to write down f prime x. So I've differentiated it. 4x cubed. And then we'll differentiate that again. And so forth. We can just carry on going down. Okay? So 4 times 3, 12, and you get x squared. This process is differentiation. Okay? The reverse process is called integration. You might want to copy this down. So integration is the reverse of differentiation. That means if you give me the gradient function f prime x and I integrate, I get fx. Okay. Now, the way we can lay this out, let me follow this with one or two examples. If I said dy over dx, or in fact, before we do that, let's just lay out the rules for integration. Let's say dy over dx equals ax to the power n plus b, then y equals the integral, and there's the integral sign, of ax to the power n plus b, and I'll write this out in a second, and this dx means with respect to x, I'll write that out in a second, and the formula for it is you raise the power by 1, divide it by the raised power, okay. Any constants become coefficients of x, and then you've got a constant of integration plus c in our general solution. So let me just fill in, let me just add a couple of notes. There's my integral sign, that means I'm integrating. Dx means with respect to x, because that's my variable, okay. Later on, as you'll see, you might have other variables like t or v, for example. And this part here is also quite important. This is called the constant of integration. And let's put that in a box. So this is quite an important line you need to copy down. And that tells you how to integrate. So if you give me the gradient, and you want to work out the original function, you can integrate the gradient by raising x to the power of 1, dividing by the raised power, and so on. Okay? With respect to. Okay, so with respect to. WRT. And so, if we've got, for example, dy over dx equals x cubed, we want to work out y, we'll integrate x cubed with respect to x. We raise the power by 1. I'm not even going to write down 4. I'm going to tell the examiner what I'm doing. I'm going to show with my method marks, and then plus some constant c. So this will give us x to the 4 divided by 4 plus some arbitrary constant c. Let's do another one. Say I've got this time, let's use different letters, ds over dt. ds over dt is 3t to the power 4. We want to work out s. So we integrate 3t to the power 4 with respect to t. This time we raise the power by 1. In fact, let me show the method marks. Let me show the method. So I'm doing 4 plus 1 divided by the raised power. Okay, and then plus some constant c. And that gives us 3t to the power 5 divided by 5 plus my constant c. Now this constant c, this arbitrary constant, okay, is 1 mark, normally 1 mark in an exam. Okay, one nice easy mark. Make sure you don't lose that. And that's for a general solution. The general solution, remember, covers all the possible cases we can get. One of the ways you might want to think about the bx part, so over here guys, we've got a question about bx plus c, where does that come from? Firstly, you always add a constant. Okay, you always add the c. Why? Because we just established from when we looked at the reverse process, we were adding a c. Yeah? When we're looking at the reverse process, we will add a c because we saw that the general solution, the plus c can be anything, it doesn't really matter. But pretend this was my equation, I'll get x cubed. Pretend this was my equation, I'll still get x cubed. Okay, so therefore you need that plus c in there because it's a general solution. Now the bx part, one way you can think about it is next to this b here, okay, you've got x to the naught. And so when you raise the power by 1, it becomes x to the 1 divided by 1. That's one way you can look at it. But basically, when you're integrating a constant, it becomes the constant times x. Okay, because of the reverse process. Now, look, if you were to differentiate bx, you'll end up with b. Okay, so that's essentially what it is. The integration is a reverse of differentiation, and we do it by raising the power by 1, dividing by the raised power, doing that for all the terms, and then adding a constant of integration. Is that clear? Is that okay? Alright, great. Let's have a look at some questions. I'll put a couple of these up and then we'll go over them. I'll give you about 5 minutes to do them. Can you have a go at these questions here? Okay. Okay, there you go. Alright, off you go. I'll give you about 3 minutes, 3 or 4 minutes to do. So, with the first one, what do we get? Y equals, what do you get? x4 over 4 plus
3x squared over 2.
Excellent. Plus
2x.
Plus c. Excellent. Well done. Okay, the next one, Francesca.
I was doing questions.
Okay. Angel. Okay, hang on. 4 over 3 x cubed minus 5 over 2 minus x plus c. Excellent. The next one, Charlie. Okay. Alana.
Is that the third one?
Yeah.
I didn't get that one.
Okay, who did? Hands up, who did? Okay, Jude.
X cubed over 3
Okay, let's expand this out. So you get x squared
plus x minus 6
plus x minus 6, and therefore y equals x cubed over 3.
plus 0.5x squared
Yeah.
minus 6x plus c.
Okay, excellent. Okay. Now, all of these solutions are general solutions. The reason why they're general is because we have the plus c. And that plus c means c can be any real number. Okay. But what if we don't want a general solution, we want a specific solution? Well, then we need to specify that in the actual question. And here's such a question. Let's look at example 3. Okay. So the gradient of a curve is given by dy of dx equals x squared plus 2x plus 1. Okay, the curve passes through this point 1, 5. Find the equation of the curve. First thing, with dy of dx, if we expand that out, we've got 2x cubed plus x squared. What can we do from here? How are we going to find the equation of the curve? Integrate. So if you integrate, let's write that out, 2x cubed plus x squared dx. Okay. Giovanna, what do you get for the first term?
You get 2x, well, a half x. Well,
Yeah, excellent. So yeah, so that's just 2 divided by 4, which is a half. Yeah. Okay. For the second term, Whitney, what would you get for x squared when you integrate it? Okay, Sumaya, do you want to jump in? Sorry, Shami, do you want to jump in? X squared when you integrate it.
X cubed.
Right. So you raise the power by 1, divide it by the raised power. Is that okay, Whitney? Okay, let me come back to that. So when we're integrating, you raise the power by 1, divide it by the raised power, and then what else do we need? What's missing?
C.
Plus C. Okay. Now they've given us some information. What have they told us about the curve? Kulsum. What have they told us about this curve? So when x equals 1, what does y equal to? Y equals 5. Therefore, we can substitute x, we can substitute y, and work out what c is. Can somebody work that out? In fact, can you all have a go at working it out? And then,
Wait, are you allowed to practice in this sequence?
yeah, you can use a calculator if you want. Excellent. Okay, so c equals 25 over 6.